Excellent. Right. Yeah, no, thank you very much for coming along, everyone. Thanks for the introduction, Emily. I'm Bob. I'm currently working at the National Museum of Scotland, looking after the geology labs. I also run the sort of analytical facilities, where we look at geological materials of varying descriptions. This evening I'm going to talk a bit about the Isle of Arran, some of its geology, this curious phrase that you see absolutely everywhere. So I love Arran. I've spent an awful lot of time on Arran. I've explored most of the island, I think. I first went with a geology society field trip at university when I was doing my degree at Edinburgh. And then I ended up doing my PhD there with Cardiff University, studying some of the rocks in the middle of the island. So this is this title slide is the summit of Ardven, a hill in the center of the island, looking north towards the big mountains in the north. So that was my PhD study site. And then, yeah, as Emily said, I then ended up moving there for a year and a half to help set up the fledgling Arran Geopark. So I'm sure a lot of you will have been to Arran. If not, I would highly recommend it for absolutely everyone. If you're planning a visit, let's see how this works. If you're planning a visit, you'll probably I don't know, type in something like things to do in Arran into Google, and you'll get something like this from Visit Scotland, the national tourist website, and you'll see it's Arran, Scotland in miniature. Oh, that's nice. Oh, a little bit of everything you'd ever want from a Scottish island, and you'll think, oh, that's nice. There's probably, you know, walks and beaches and golf and whiskey and all that lovely stuff. And then you'll maybe read some travel blogs, and you'll see it there, and you'll see some more travel blogs, and you'll keep seeing it. And you'll read some magazine articles. Oh, there's Scotland in miniature. Scotland in miniature. Yeah, okay. I'm starting to get it. You read some more articles. Maybe you want to do some walking. You'll go to Walk Highlands. That's Scotland in miniature. Some YouTube videos. Right. Okay. Right. We get the picture. Some photo books. Right. A Paul Merton TV show. Right. Okay. And then there's even papers on the housing crises in Scotland. Scotland in miniature. Okay. So it's perhaps, in my opinion, becoming a slightly overused and irritating phrase. And you start thinking, yeah, it's a nice little sort of tourist sort of snappy slogan, but it is actually mean anything. It can't possibly actually be particularly meaningful in any sort of scientific geological sense. So that's what we're going to unpick today. We're going to look at the geology of Arran. I'm going to take you through the geological story of the island. And we're going to compare that to Scotland, and Scotland's obviously so huge and geologically diverse that we're going to see that there's no way you could actually go on giving it this sort of haughty title in any meaningful way. So if you're unaware, this is Arran down here in the Firth of Clyde in southwest Scotland. It's about 20 miles north to south. A few settlements, almost all on the coast of the island. Brodick and Lamlash are the main two. Most of you, if you get the ferry, will come into Brodick on the big one from the big boat from Ardrossan if it's running. And then, yes, sort of smaller villages around the coast. Lochran's up at the top. That was where I was based for a while. So we're gonna look at the geology and some of the landscapes of the island. So take you through its very varied geological history. It is such an amazingly geologically diverse island. There's a reason that it's always swarming with geology undergraduates, because it is the absolute perfect place to learn about geology and see a whole host of different rocks and really cut your teeth looking at these sorts of things outside. So if you've ever been in any geological classroom in the country at all, you will probably have seen this map. This is the solid geology map of the island of Arran. If you're not used to looking at geological maps, this one on the left is probably looks a bit overwhelming, quite confusing. There's an awful lot of information and funny little lines and symbols that nobody understands. So today we're going to be using this one on the right, which is an incredibly simplified one, but it basically shows you all the main different types of rock unit that we're going to be looking at today. And then along the bottom here, I've got a wee timeline. So just to keep us sort of in order with what age all these rocks are and what order all the events are happening in. So that's today at the right here, going back all the way through the Cambrian, 500 million years. That's 500 million years and into the Precambrian. So Arran's story starts round about, just over 500 million years ago, just this side of the end of the Precambrian. So roughly 540 million years ago, what was going to become Arran was somewhere near the South Pole, probably, and it was in the ocean off the coast of this ancient continent called Laurentia. So to give you an idea of sort of how long ago that was, the very first animals with hard skeletons and shells had only just evolved at the start of the Cambrian. So things like the trilobites and basically most animal body plans that we recognize today have only just started to evolve. So we're going back quite a long way in Earth's history. So at the bottom of this ocean, you've got erosion on this continent, all this muck sort of getting washed into the sea and very gently settling down, forming layers of mud and sand and silt at the bottom of the ocean. And it's all very quiet for a very long time. But then something starts to happen that is going to change these rocks. If you look at the map of the timing around about 100 million years into the future, about 450 million years ago, this continent of Laurentia is starting to collide with all these other little continents, like Avalonia, which will one day become most of England, Wales, and Ireland, and then Baltica and Siberia. And the Iapetus Ocean is disappearing. It's being swallowed up. And what happens when you have a closing ocean and continents colliding is you get what's called an orogeny, which is a mountain building event. So that's exactly what we're seeing today with the Indian subcontinent colliding with the rest of Asia, and that's what's throwing up the Himalayas, and similarly Africa and Europe are colliding, and that's what's throwing up the Alps. So around about this time, what's forming on this side of Laurentia is this vast mountain range that we now call the Caledonian mountain range, that would have been comparable in scale to the Himalayas. Huge mountains, going on for hundreds of miles, and deep below all that, those sands and silts and muds that we met back in the Cambrian, they're being squeezed, they're being deformed, they're being heated up, they're being metamorphosed, and they're being deformed. So they're crumpling, and the heat and pressure is causing the minerals in those rocks to completely change into metamorphic rocks, and so that's what you see around the north of the island. They're called the Dalradian Schists, and it's this grey unit on the map that forms an almost complete ring around the north of the island. So these ancient hard metamorphic rocks. On Arran, they tend to be sort of these dark grey slates and schists. You'll see folding, buckling in them formed by all this pressure. There are a few slates that have been quarried in the hills just to the east of Loch Ranza. There's some old slate workings. It wasn't the best stuff, and there wasn't much of it, and it obviously was so difficult to actually get out of the ground that they didn't do a great deal with it. But I think there are still some buildings around the north of the island that have Arran slates on their roofs. So that's the Caledonian Orogeny. Now, while this is all going on, while this old ocean is disappearing, and all these bits of continental crust are sort of being rejigged and slid past each other and across each other, some of the stuff actually from this ocean is being caught up in this whole thing. So if you follow a line from Arran sort of northeast towards Stonehaven, you'll come across this string of very strange rocks that seems to have formed in an ocean and haven't quite been affected by the Caledonian orogeny in the same way that those earlier older rocks were. So this is called the Highland border complex, and it's just this purple unit there. You cross it if you cross the bridge in Glen Sannox, North Glen Sannox, on the way to the north of the island. You'll cross this Highland border complex. And they're mysterious rocks. They're very deformed, but they're very interesting. And if you go on a nice day in sort of around the Easter holidays, you'll probably see a whole lot of geology students standing in the burn. And what they're looking for is these strange igneous rocks. So they're the volcanic rocks that have this funny blobby appearance. And these are called pillow lavas. So pillow lavas are what what forms when you've got an eruption of lava underwater. And there's a video here of some forming. So you've got this incredibly hot lava, you've got cool water, and as soon as that sort of hot molten material comes into contact with the cold water, it immediately quenches and solidifies into this black crust. So you can see here that it's sort of pushing itself out of these pillows, and that's how it grows and erupts, and that forms these very typical sort of blobby basalts that you can see in North Glen Sannox. So try and move on. There we go. So now we move forward to about 400 million years ago. We're into the Devonian. And you'll see this continent is now taking shape, and you'll see that where Arran is, the star, is roughly sort of 30 degrees south of the equator. And if we think about the modern globe, 30 degrees north and south of the equator, that's where we get the deserts. So you've got very arid environments. There's not really much living on land yet. Barely anything at all is actually living on land. So you've got this hot environment, very dry. And this mountain range, this Caledonian mountain range, it's no longer being sort of shoved up by tectonic forces. It's now starting to erode. So it's starting to, the powers of wind and rain are causing the erosion up in the high mountains, and that's generating a huge amount of sediment that's then being moved down into sort of steep arid valleys, into these steep alluvial fans. This is an alluvial fan in Death Valley, which is probably roughly what the sort of environment that you'd be seeing back in the Devonian. And it forms this unit called the Old Red Sandstone, and that's this darker brown here, again around the sort of north of the island. The best place to see it on Arran is the beach around north of Corrie and around Sannox along here. It's where you get these really nice deep red sandstones and conglomerates. And occasionally you see evidence of sort of quite powerful rivers churning these pebbles into these nice rounded shapes and then depositing them as conglomerates. So the Old Red Sandstone is actually an incredibly, it's a huge unit of rock. So this is a map of where you find it all over the country. So down here, you see it in Devon and Cornwall. So that's actually where we get the name the Devonian for this time period, is the sandstones in Devon. This image, that's Pen y Fan in the Brecon Beacons in South Wales down here. There's loads of it down there. You see a lot of it in the Midland Valley of Scotland, and then up here, Caithness, Orkney and the Murray coast, and this area called the Orcadian Basin, which is where a lot of the amazing fish beds are found. So you can imagine how big this mountain range must have been and how much erosion there must have been to get this thickness of sediment, hundreds of meters thick, kilometers thick of all this red sandstone covering what is now the entire country. So it must be an absolutely phenomenal amount of sediment being moved around. So jump forward a little bit into the Carboniferous, and you'll see that on its sort of continuing march north, what is going to become Arran is now roughly on the equator. So if we think of the analog of the modern globe around the equator, that's where we get the tropics. So sort of, very hot, very humid, very wet, swampy environments. And if you go and look at the Carboniferous rocks, so the Carboniferous on this map is this light blue color. It's a fairly skinny little band, but it's where a lot of the interesting rocks in Arran are. If you go up here, right to the sort of the remote northeast coast of the island, you'll find this strange trackway in one of the limestone units. And that is actually, it's a trace fossil. So it's the fossil left by the feet of this creature called an Arthropleura, which is a kind of giant millipede that lived in the Carboniferous. And these are thought to have grown up to around about 2 meters long, which is absolutely enormous. They're the largest land-dwelling invertebrates that we've got any record of. And we've never found a body fossil of one of these in Arran, but there's this amazing trackway up near Lagan. And there's also some evidence of the burrows of these things on the beach at Corrie, just outside the pub. And you also see other fossils. This is from some building work that was going on in Corrie a few years ago. This is actually thought to be the imprint of a tree root. And so these sorts of rocks suggest that the environment was something like this. This is your classic reconstruction of the Carboniferous swamps. So you've got these very primitive plants. They're not really trees; they're more like club mosses, but they grow incredibly large. In all of these, there's always a picture of a giant dragonfly, because oxygen levels were higher than they are today. So it allowed things that don't breathe air into their lungs and take it in through their skin. It allowed them to get very big. That's why you have these huge millipedes and these enormous dragonflies. And so these trees grew incredibly quickly in this humid environment, and then they would die and they'd fall over and they'd collapse. And the sort of the biology of the sort of detritus breakdown, bacteria, fungi, bugs, and things like that wasn't quite as developed as it is today. So these things didn't actually rot in the same way that we'd think of fallen down trees doing that today. And so they just built up. They built up and built up and built up. And then eventually, once they were turned into rocks and put under heat and pressure, that's what we now know as coal. So the coal deposits of Britain and sort of Central Europe, and then places like Pennsylvania in the United States, there's all these coal deposits are from these Carboniferous equatorial swamps. Elsewhere in the Carboniferous, on Arran at Corrie, we see evidence of marine life. So this is one of the famous limestone quarries at Corrie, and you look up in the ceiling and you see all these things that they're about the size of cricket balls, and these were giant brachiopods, which are like the bivalves that you see at the sea, basically like huge clams, but biologically quite different. But they, the same sort of animal. These big shellfish that live in nice, sort of warm, shallow tropical seas. So at the times during the Carboniferous, when the seas sort of covered the land, it would have been sort of like the Bahamas. Would actually have been quite nice, actually. So corals and crinoids, you get all these sorts of things, and you can find all these on the limestones at Corrie, and further up north as well. So this is a reconstruction of the sort of Carboniferous seafloor in Arran, sort of 340 million years ago, something like that. So these are crinoids. These are animals. They're not plants. So yeah, quite a weird ecosystem. But you see fossils of these all over the place. Also in the Carboniferous, there's a lot going on in this little blue stripe on the geological map. It's also a time when Scotland is volcanically active again. So here we've got Arthur's Seat in Edinburgh. That's Castle Rock. These are the hills sort of between Glasgow and Stirling, the Campsie Fells, and all of these landforms are volcanic. They're volcanic rocks from the Carboniferous. And so we do have evidence of this at Corrie. There's some lavas, and this would have been this sort of oozy sort of lava type eruption, where you've got, like you see here, and this is Hawaii a few years ago, and this is Iceland, where you've got the crust pulling apart a little bit, and that allows all these cracks to form, and lava oozes out. So you've not got big explosive eruptions. It's just building up, lava flows on top of lava flows on top of lava flows, and that's where you get these big buildups of lava in across central Scotland. So here's some more video. This is, I believe, from Hawaii. So yeah, this is how this sort of volcanic deposit builds up in the geological record. You've just got this oozy lava. It's the sort of thing that people can go and, tourists can go and see when it's happening in Iceland, because it's not actually that dangerous. You can walk away from an oozy basaltic lava flow. So you can get quite close, and they're very impressive. So you imagine these building up and forming huge thicknesses of of basalt in the geological record. That's what we see in places at Corrie. So this is a photo from Corrie, and you can see these sort of hexagonal shapes. And these are exactly the same hexagonal shapes that you'd see in the columnar jointing at the place like the Giant's Causeway, and also Mull and Staffa on the west coast of Scotland. These are a lot older, and these are still about 340 million years, 335 million years old. But it's the same idea. You've got these big, sort of flat level deposits of lava, and it starts to cool, and as it cools, you get these cracks propagating through it and forming these sort of polygonal patterns. So now jump forward to about 250 million years ago. You'll see that Arran is continuing its march north, and we're now about 30 degrees north of the equator. So we're now at the same sort of latitudes that the Sahara Desert is today. So if you follow the old Red Sandstone through the Carboniferous into the new Red Sandstone, you actually get this really nice sort of symmetrical track of Arran's move across the equator. So these are some of the fantastic red sandstones that you get along the coast between Brodick and Corrie. Again, this one's from Corrie. There's an awful lot of Corrie. It's worth a geological visit, definitely. And so these were deposited by sort of what you think of as desert sands, aeolian sand dunes being blown around, all these little tiny grains of quartz bumping into each other and becoming very round. And as well as the cross-bedded sandstones, there's also mudstones, especially around the south of the island. And these mudstones have some more trace fossils, so no body fossils, but you see these sort of footprints and what look like handprints. So this is one of the first ones that was discovered. This sort of hand-shaped imprint from near Blackwaterfoot. It's actually just north of the Dromadoon Point up there somewhere. So this thing it's become known as the hand beast of Blackwaterfoot because its footprints look like big handprints. And along the south coast, you'll see the same things, but with this sort of right left pattern, which shows that there was these creatures walking across these sort of arid mud banks back in the Triassic. So again, on Arran, we've never found the skeletons of the creatures that made them, but they're thought to be sort of very primitive crocodile-like things. So this is the Triassic. It's the sort of time. It's the same time as the earliest dinosaurs, but the creatures that made these are more closely related to crocodiles than dinosaurs. And so the name of this fossil is Chirotherium, which does mean hand animal because of these hand-shaped prints. The strange thing is that one is actually let me think. It looks like a left hand. It's actually a right leg. So that's his right foot. And that thing that looks like the thumb sticking out, that's actually its pinky toe. So you can see here the paleo artist here has shown the sort of the pinky toe sticking out to the side. So yeah, strange trackways, but when you find them on the beach down on the south coast of the island, they're really impressive. They're really cool. And probably one of the most notorious, infamous fossils, if you can call it that, on Arran, is this strange marking. Again, not far from the pub in Corrie, in the Permian sandstones. So this whole thing's about only, it's less than a foot across. It's a small thing. You see people looking for it, and they never know quite where it is. But this is thought to be, I'm convinced that it is a paleofulgurite. So fulgurite is what happens when lightning strikes sand, and that intense burst of heat sort of fuses all these sand grains together to give you a sort of glassy tube. And you find them in modern deserts and on modern beaches. But as far as I know, these ones at Corrie, there's 3 of them that I know of. They're the only sort of convincing examples of these things in the geological record. So they're incredibly interesting things, and yeah, people spend many sort of happy afternoons trying and completely failing to find them on the beach. So yeah, if you manage to find one of these, well done, you're doing quite well. The new Red Sandstone has been quarried as a building material. You'll see it all over the place. So this is Brodick Castle at Brodick, and then Lochranza Castle up in the north. You can see they've used it as a sort of decorative cornering stone. You see it throughout the sort of the Clyde coast, Troon Harbour, I believe. The whole thing was built out of Arran sandstone. So yeah, it makes a lovely building stone. So if you're in that part of the world, keep an eye out for it. It might be rock that was quarried on Arran. Now we come forward into what I think is the most interesting part of Arran's history. So we've jumped forward quite a bit in time. We're now 60 million years ago. You'll see that in terms of latitude, we're approaching our current position up in the northern hemisphere. Now, 60 million years ago, two related things happen. So we have this hot plume of mantle material ascends from deep in the mantle, and it reaches the Earth's crust, and also the great continent of Pangaea, which has been splitting up for a few million years by now. The northern part of it is now starting to break apart. So we've got Europe and North America, which have been part of the same continent, are starting to tear apart from one another. And so this combination of the tearing apart of the Earth's crust and this mantle plume appearing at the bottom of the crust, it causes a huge amount of melting. So you've got all this molten material in the crust working its way towards the surface, and either getting stuck on the way there as granites and gabbros, or erupting at the surface as volcanoes. So we see it all up the west coast of Scotland. So here we have lava flows from Skye. Actually, these ones are from Mull. Again, you see the very typical sort of topography where you've got these steps. These are all individual lava flows. So yeah, so Skye and Mull, that's most of the landscape of these areas looks like that. And then this is the gabbro coolants in Skye. So gabbro being what happens to this material when it doesn't quite make it to the crust. It stays at depth and it slowly crystallizes, gives you this really tough sort of coarse-grained material that's absolutely excellent for climbing, but chews through your boots. So on Arran, all this magmatism going on at 60 million years ago, probably the most obvious expression is this huge big red blob on the geological map. So this is the North Arran granite. So you can see here the mountains of the north. This panorama, that's all granite. That's all just this one big intrusion of granitic stuff. Now it was originally thought that this granite sort of moved up through the crust like a big spherical balloon, and I partly blame Arran for that, because people sort of saw this big circle and thought, oh, it must be a big circular blob in all directions. But we now think it's more like this. It's more like a sort of blister, where this granitic material is sort of injected into the crust and pushed all the stuff above it out the way. And you can tell that, you can sort of map the bending and folding of the rocks around the granite. And you can see it's actually all been pushed up by the emplacement of all this material. And then one of the other sort of spectacular landforms in Arran is this thing, is the Dalradian Sill. So that's this green blob here. So these green blobs, these are all sort of sheets of magma that pushed their way sort of through the crust. So here's a diagram of the formation of the Dalradian Sill. So this is all the Permian and Triassic sandstones. So you've got these flat, sort of finely bedded sedimentary rocks, and so the surfaces between each layer of those sandstones is a weakness. So rather than bother pushing its way all the way up to the surface, the magma in this part of the island especially tends to just sort of push its way along one of these weaknesses in the crust, and that's what's forming all these sills. You can see them all. There's quite a few spectacular ones around the coast around Lamlash as well, and so there's some waterfalls around the side of the island where rivers sort of pelt off the top of these things. Holy Isle, that's geochemically quite weird and interesting. It's different from all the stuff actually on Arran, but that's another one of these sort of sheets of magmatic material. Another feature that you'll see, especially if you go for a walk along the beach, you see these walls of black rock. This is an aerial image of the coast at Caledonian down in the south here. And these are known as dikes. So this is a picture of one of these dikes, sort of big black wall. And that there is Plada. That's this little island off to the south here, which I actually heard was up for sale recently. I don't know if anything's happened to that. But it's this little island with a lighthouse, and that's one of these sills as well. So these dikes, these are thought to be the remains of the plumbing system that would feed eruptions like this sort of thing. These big fissure eruptions that we see in Iceland. So as North America and Europe are pulling apart, the crust responds by basically cracking. So if you think of pulling apart a Mars bar or something, and all that chocolate cracking and giving space for the caramel to sort of ooze up to the surface, if you'll permit the extension of the analogy. So it's the same sort of stuff as basalt, as lava flows, but it's just stuff that is thought to be the sort of the fossilized cracks that the lava was using to make its way up towards the surface. And then, in my opinion, the most interesting bit of the whole island that I spent 4 years of my life doing a PhD on is this orange blob in the middle. So this is the central complex, and by that we may basically mean it's the site where there was an enormous caldera volcano. So there was a huge volcano centered right in the middle of the island. So a caldera volcano is a very large, very sort of violently explosive kind of volcano. So the eruptions, when it erupted, it would look like this. You'd be seeing plumes of ash and dust being sent, kilometers up into the stratosphere. This is an image of Mount Redoubt in Alaska in 1990. This would have been, smaller than your average Arran eruption. And a caldera itself, this is Crater Lake in Oregon. It's a huge depression. It's bigger than a volcanic vent. It's actually formed when so much magma is sort of drained out of the magma chamber below the volcano that the landscape just collapses in on itself. So we would have had this huge collapse structure about 4 kilometers across in the middle of the island. And the eruptions that formed that must have just been absolutely cataclysmic. So again, we've got some more footage. So again, this sort of eruption would have been a small one for the Arran Central Complex when it was in full swing. So you can see how much rock. These are huge rocks just being blasted out. The amount of energy required to you can see how big those waves are. This is what Central Arran would have looked like. This is what would have looked like if you looked across the Clyde from Glasgow, if either of those had existed at the time. So these are the sort of rocks. This is all that remains on Arran of the enormous eruptions. So you can see these big blocks of all sorts of stuff. Basically everything that the volcano has just blasted through, and it's all sitting in volcanic ash. This orangey stuff, that's all volcanic ash. And you get huge thicknesses of it up in the hills on Ardven here in the center of the island. So it's only preserved in Central Arran. You'd expect that you'd see this stuff blanketing the whole west of Scotland, but it seems to have only escaped sort of more recent glaciation by sort of collapsing into the caldera as the whole thing subsided. But yeah, depending on which way the wind was blowing, this stuff must have covered the whole of southern Scotland. It's sort of quite humbling to try and sort of sit on one of these nice rocky exposures up on the hill and sort of try and contemplate the whole thing. So we're almost at the end of Arran's geological history. We've got all the rocks in place, but obviously the landscape didn't always look the way it did today. So the landscape, especially in the north of the island, has been almost entirely controlled by the coming and going of the ice ages. So for the last 2 million years, the northern latitudes have been sort of covered by ice, which is then melted, and that cycle goes sort of repeats. So you've got the, you know, ice age grows and then it all melts and you have an interglacial. So we're currently just in an interglacial. We would expect, you know, human-driven climate change notwithstanding, that there would be another glaciation on the way, but who knows? So if you look at the sort of the topographic map, you'll see these huge big glens that have been scoured out of the granite. And it's, you know, it's this stuff that makes the amazing walking up in the mountains of the north of the island, is these really steep ridges between the scoured glens. So that's Glen Sannox there. You've got this classic U shape that you'd see in a sort of geography textbook. So that, you know, this is what Glen Sannox may have looked like if you were there 20,000 years ago. So, you know, this ice has got huge erosive power. It's got so much more erosive power than any other force. And so even the granite, which is incredibly tough, which is why there's, you know, high ground in Northern Arran. The glaciers just scoured it all away. On a sort of slightly larger scale, the Firth of Clyde is basically a fjord. You had huge streams of ice pouring off what is now probably around about the area of Rannoch Moor. So the Kilbrannan Sound, which is the water to the northwest of the island between Arran and the Kintyre Peninsula. If you look at that on a map, you can see that's just it's just a really deep glen that's been carved out by a glacier, sort of scouring out towards the south. And again, if you were to fly a helicopter over Ciar Mhor 20,000 years ago, this is the sort of thing you would have seen. This is a feature called a nunatak. It's basically just the very tip of a mountain poking out above the ice. And these mountains, they're almost 900 meters above sea level. You know, this ice was a kilometer thick. It's, you know, a huge erosional force. So there we go. So that's a sort of whistle stop tour, sort of Arran's geology. But to answer our question, we need to look at how similar is that to Scotland. You know, Scotland's huge. There's loads going on in Scotland. So we're going to have a very quick and condensed, to the point of being completely ridiculous, overview of the geology of Scotland. So you'll see it's sort of, Scotland's made up of these 5 blocks that are called terrains, and these are sort of separate bits of crust that were all assembled during that Caledonian Orogeny, and they've all got their own geological history. So up here in the northwest, we've got the Hebridean terrain, so the Outer Hebrides, Skye, Clontyre, and then the Northwest Highlands. And so this is made up of the Lewisian gneiss, which is one of the oldest rocks in Europe. So there's some bits of the Lewisian gneiss have been dated to about 3.3 billion years old. So hugely older than anything in Arran. And then you've also got the Dalradian Sandstone, which is a huge thickness of sandstone, about 1 billion years old. And it's incredibly old, but it's still as fresh as the day it was laid down. It's an incredible rock. And then you've got this structure called the Moyne Thrust, and you cross the Moyne Thrust into the Northern Highland terrain, which is the stuff in green. And this is made up of old metamorphic rocks called the Moynes. And then you cross the Great Glen Fault. So, you know, the Great Glen, like the huge glen between sort of Fort William and Inverness. That's a very old geological feature. And the other side of it, you've got the Grampian terrain, where we have the Dalradian metamorphics. So we've met the Dalradian. So the Moynes and the Dalradians, they're sort of fairly similar sort of age, mostly sedimentary rocks that were metamorphosed and deformed during that Caledonian Orogeny. Then we have the Highland Boundary Fault, which is this great lineament that separates sort of traditionally the Scottish Highlands from the lowlands. And you cross that into the Midland Valley. So that's much more complicated than I've got it here, but basically upper Paleozoic sediments, lots of Carboniferous sedimentary rocks, all the coal in the Lothians in central Scotland is in this area. And then you've got Carboniferous lavas and intrusions. So you've got the Clyde Plateau, so the Campsie Fells and all this sort of high ground around Glasgow. That's all Carboniferous lava. And then you've got the intrusions, so Salisbury Crags, Dumbarton Rock, all these sills that intrude the valley. The Ochils and the Pentlands are actually slightly older volcanic rocks. And you cross the Southern Upland Fault into the Southern Upland terrain. And again, we're back into sort of high ground. And that's all, it's older sediments generally than the Midland Valley. It's this lower Paleozoic stuff. So this is actually sedimentary rocks, sediments that were deposited in that old Iapetus Ocean that no longer exists. And as the Iapetus Ocean was subducted underneath Laurentia, all this sort of muck that was at the bottom of the sea was sort of scraped off onto the overriding continent. So that's basically, in a rather disparaging way, what the southern uplands are. And then these all these funny blobs, these are igneous rocks. So you've got the Caledonian granites. So again, from the time of this huge mountain building event, deep down below that mountain, there was so much pressure and so much heat that some of the rocks were actually melting and forming these granites. So you get the famous Aberdeen and Peterhead granites and all these Cairngorm granites, and there's some in the south and up in the north as well. And then we've met the sort of the Palaeogene igneous rocks, the Skye and Mull lava fields, and then the sort of the central complex, the sort of volcanoes of Arran, Mull, Ardnamurchan, and Rum, forming this sort of string up the west coast of Scotland. So let's finally compare. Let's finally get rid of this idea that Arran can go around calling itself Scotland in miniature. So these are all geological features of Scotland. So we've got ancient Precambrian metamorphic basement. No, there's none of that in Arran. So Scotland's geological history goes back 3/4 of Earth's history, back to more than 3 billion years ago in the Lewisian gneiss. Arran's got nothing nearly that old. Arran, the oldest rocks in Arran are about 1/9, the last 1/9 of Earth's history is recorded in Arran. So Caledonian metamorphic rocks. Okay, yeah, we've got that. We've got the Dalradian Schists, sort of represented the Dalradian. Lower Paleozoic ocean sediments. So the southern upland stuff, I felt a bit silly putting a tick there because it's only tiny little bits in the Highland boundary, in the Highland border complex. But yeah, we technically have stuff like you see from the lower Paleozoic, upper Paleozoic marine sediments. Yeah, we've got all those things that are full of fossils at Corrie. The coal measures, yeah, okay, we've got that as well. Carboniferous igneous rocks, yeah, okay, we've got those as well. Big scary Mesozoic beasties. I had to say that because I couldn't say dinosaurs because we don't have any evidence of dinosaurs on Arran. But there's dinosaurs in Scotland, but it's the things that weren't the dinosaurs which I think are more interesting. Yes, we've got those in Arran. We've got big sort of crocodile-y things roaming around in the Mesozoic. Palaeogene volcanic stuff, granites, dikes, yeah, we've got that as well. And then these sort of fantastic Scottish landforms, corries, U-shaped glens, arrests. Okay, so maybe Arran does have some of the same stuff that we find all over Scotland. But I think when people say Scotland in miniature, they're looking at a sort of slightly bigger picture, sort of landscape level stuff. So let's have a look at that. So we've got both Arran and Scotland in the north. They're mountainous, they're old metamorphic rocks, yeah, intruded by granites. Yeah, we've got the granite here. We've got all these granites in the Cairngorms. Deeply glaciated, so we've got the fjords and these U-shaped valleys. It's what we see all up the west coast and in the Highlands. And what sort of travel guides would call rugged scenery. It's steep. It's covered in heather. There's sheep farms and not a great deal else other than tourism. Then we've got the middle. So we've got the Highland boundary fault. Runs through the middle of Scotland, runs through the middle of Arran. And it's sort of where all the people live in the middle. You've got Brodick, Lamlash, Blackwaterfoot, sort of along this sort of lower area between the hills of the south and the mountains of the north. And then both Scotland and Arran in the south, they're lower but hilly. They're made of these sort of sedimentary rocks that have been intruded by sills and sheets and other sorts of magmatic intrusions. The dominant landscape features tend to be river valleys. So in southern Scotland, you've got the Forth, the Clyde, the Tweed, and then Arran, you've got the Macquarie water, the Slidery water, all these sort of deep glens that are proper river glens rather than glacial features. And what landscape that you'd call more sort of mixture of urban and rural rather than remote, which is its own term as well. So they're what I think are the sort of the things that the sort of both Arran and Scotland have. So I think based on geology and landscape and yes, even that sort of all that sort of cultural tourist stuff that I think Visit Scotland are going on about, I think I am forced to admit that Arran is indeed Scotland in miniature. Thank you for your attention.